Hello students, hope you're all doing well. Welcome to another video by Quick Study. Today we will be starting another topic of GCSE Physics, and our topic for today will be magnetism and electromagnetism. So before getting to know about magnetism, we must know about magnetic field. A magnetic field is the area around a magnet where magnetic forces can be felt. Using this magnetic force, the two magnets basically attract or repel each other. Field lines are the invisible lines which are included inside the magnetic field. They cannot be seen. They basically run from north pole to the south pole of a magnet. There are two types of magnets. One are the permanent magnets, another is the induced magnet. Permanent magnets are always magnetic. Where whenever you put anything magnetic near it, it will attract the north to south pole of it. Another one is the induced magnet. It will only become magnetic when it will be put inside a magnetic field. Electromagnetism, on the other hand, is created by electric current. A type of magnet where the magnetic field is created by electric current is known as the electromagnetism. It is basically made by wrapping up wires around a solenoid. We can adjust its strength by increasing the wires or adding more turns to the coil. We may have heard about this line that opposites attract each other. This line comes from the magnetism rule, which is if a magnet's north part gets close to another magnet's north part, they will basically repel each other. But if a magnet's north part gets close to the south part of a magnet, they will basically attract each other. This is where the term comes from, that opposites attract each other. Let's look at a rule by which we can know the directions of the magnetic field and the current by using this rule. This is known as the Fleming's left-hand rule. A stronger force will be produced if the magnetic field is stronger or if the current is increased. If we change the direction of the magnetic field, a different overlapping pattern is created, and we will see the wire move in the opposite direction. This is basically Fleming's left-hand rule, where the thumb will be the direction of the motion and the first finger will give the direction of the magnetic field, and the second finger will basically give the direction of the current inside the wire. While talking about magnetism and electromagnetism, we must talk about transformers. Transformers are devices that change the voltage of an alternating current either by increasing or decreasing the voltage. They are basically made of two coils: the primary coil, where the input voltage is applied, and the secondary coil, where the transformed voltage is produced. We all obviously have a formula where it shows how the voltage is being transformed, which is Vp divided by Vs is equal to Np divided by Ns, where Vp is the primary voltage and Vs is the secondary voltage. Similarly, Np is the number of turns in the primary coil and Ns is the number of turns in the secondary coil. So this figure basically shows how a transformer is formed. It shows the primary coils and the secondary coils, and also how the voltage is inputted and what the output voltage is. So let's do an example we can do with the formula we just learned. A transformer has 100 turns on its primary coil and 500 turns on its secondary coil. If an alternating voltage of 2 volt is applied across the primary one, what is the voltage across the secondary coil? So we basically have to find out the voltage across the secondary coil, which is the Vs. So we know the formula Vp divided by Vs is equal to Np divided by Ns. So let's write what we have. So putting them into the equation would be 2V divided by Vs is equal to 100 divided by 500. So doing the triangle method, Vs would be equal to 500 multiplied by 2 divided by 100. So the answer would come out as 10 volts. So the produced voltage would be 10 volts. So we also have to consider the energy inside the transformers. It is very important to try to make transformers as efficient as possible. To keep any energy losses to a minimum, we can use this thick copper wire for coils and use a soft iron core covered in a thin layer of plastic connected to two coils. If a transformer is 100% efficient, then the electrical energy entering the primary coil each second equals the electrical energy leaving the secondary coil each second. So obviously this is a formula which would be input power is equal to the output power, which basically means that Vp multiplied by Ip is equal to Vs multiplied by Is. Similarly, the V is for the voltage, and here the I is for the currents. IP is the primary current and IS is the secondary current. Let's look at an example we can do with this formula. So when a voltage of 12 volt is applied across the primary coil of a step-down transformer, there is a current of 0.4 ampere in the primary coil. We have to calculate the current in the secondary coil if the voltage induced across it is 2 volts. We have to assume that the transformer is 100% efficient. We must keep in mind that in our mathematical problems, we have to assume that the transformer is always 100% efficient unless they have said something different. So we know the formula is Vp Ip is equal to Vs multiplied by Is. So putting them into the equation would be 12 volts multiplied by 0.4 ampere is equal to 2 volts multiplied by Is. So we have to calculate the Is here. Doing the triangle method, we get Is is equal to 12 volts multiplied by 0.4 ampere divided by 2. So the answer would be 2.4 ampere. So the secondary current here is 2.4. That's all for today, students. So in this video, we have learned about magnetism, electromagnetism, magnetic field, and magnetic poles. We have also learned about two formulas which include the transformers. We have learned how transformers work and how the energy inside them work. So the two formulas we have learned will be used in different mathematical equations. Stay with us to learn more about physics and other subjects as we post regularly on our channel. If you like this video, do give us a like and subscribe. To learn more about our online tutoring services, do visit www.quickstudy.uk.